Welcome back. In lecture 23, we will talk about accessibility, the first part, and then we will, in the next lecture, we will cover the second part. The different concepts that we will cover in this lecture are accessibility definition and concept, the accessibility construct, or what exactly is accessibility, the different measures of accessibility, accessibility measures. Then we will talk about regional and local accessibility, and finally, accessibility and centrality. So, in the last lecture, we ended by saying that when we want to decide on certain choices by individuals on development, or either development of a particular land or construction of maybe a commercial area, then definitely we require more detailed information about that particular land, maybe the land price of it, and also the accessibility for that particular land. So, what is accessibility? Different people have defined accessibility in different ways. For example, Hansen has defined it by saying the potential of opportunities for interaction. That means an area which offer higher potential of opportunities for interaction has got a higher opportunity, has a higher accessibility. Then Dalby and Martin has said the ease with which any land use activity can be reached from a location using a particular transport system. So, this is their way of defining accessibility. Then the freedom of individuals to decide whether or not to participate in different activities. So, that is also one way to measure accessibility. So, this is a more individual centric view. And then the benefits provided by a transportation land use system, which is probably the most appropriate for us, and this has been given by Ben Akiva and Larman, and this is the most famous definition of accessibility along with Hansen's, and this talks about that the total benefit that a land use transportation system provide for a particular area or a zone is the accessibility of that particular zone. So, accessibility in the context of land use and transportation systems should provide both individuals or group of individuals the opportunity to participate in activities in different locations by means of different transport modes. That means we are providing we are talking about both opportunity as well as the different transport modes that are available to avail those opportunities. So, both are important. So, accessibility relates to location and access relates to individual. So, some people may confuse between accessibility and access. So, accessibility is for a zone, whereas access is for a particular individual. Now, there are also sometimes confusion between these two terms, mobility versus accessibility. Mobility primarily refers to the transportation system, that is responsiveness to change in transportation system, versus which is accessibility is responsiveness to change in transportation and land use system. So, whenever it is both transportation and land use, it is accessibility. Whenever it is just transportation, it is mobility. Sometimes people talk about accessibility to a zone or accessibility from a zone. So, this is another question sometimes that comes. Then accessibility of a person in a zone or accessibility of that overall zone depends on the purpose of the study. So, all these definitions, the way we deliberate on this particular issues would be as per the context of the study. Sometimes we may talk about accessibility to a zone, sometimes we may talk about accessibility of a zone or from a zone. So, in that way we can decide on what way we are defining accessibility, but primarily it could be used, accessibility could be used for many other things, but primarily accessibility basically refers to the attractiveness and the ease of transportation systems or the availability of transportation systems for an area, or the attractiveness of that particular location in terms of how people can get access to either jobs or to recreational facilities, and how easily they can reach those facilities. Together it creates a construct which actually helps in determining the importance of different urban areas, or it could help us in explaining that why certain things or certain land uses are coming up in certain areas. And so, this is a very, very fundamental criteria for urban planning, and a detailed understanding of the accessibility is required to predict a lot of changes in an urban area and also to understand the changes that happen in an urban area. So in that way, accessibility is very, very important. So accessibility could be also used as a social indicator, where it could be used to measure social inequality. And like, for example, certain areas have got transportation systems, other areas may not have that much amount of transportation facilities. So there is a need for improving that particular transportation component. So some people have also measured the inverse of accessibility and termed it isolation. That means how isolated a particular place is. Accessibility also could be used as a sustainability measure. For example, reducing automobile use, access to education, medical facilities, and promotion of economic development. So these are different ways we can also measure accessibility, which could be called as sustainable, gives a sustainability criteria to a particular area. And accessibility measure can be also used as an economic indicator as well. So these are different ways the accessibility could be used, but primarily it talks about the attractiveness of a particular area in terms of both access and access to opportunities and the means to access those opportunities. That means the transportation system. So accessibility construct has got two basic components. One is, of course, the travel impedance or level of service. That means how between any 2 points or between all the different opportunities that are present, what is the level of service to reach those opportunities, or what is the amount of impedance. The impedance could be both cost, it could be both time, or it could be a combination of both, or it could combine also the quality of the modes that are available, or other level of service values, or the kind of infrastructure that is there. All this makes up travel impedance. And activity attraction could be jobs, could be some other features like schools, or could be recreational areas and so on, or could be parks. So activities, different kinds of activities and opportunities that are there surrounding this particular zone, which are available to access. And in addition to that, there could be other components which could be thought of when we think about accessibility. That means the time of the day, that means at different times accessibility may vary. The activity time and spatial characteristics, like what kind of activity and when and for how long you are performing that, and the different spatial characteristics of that particular area. So this could be also disaggregate measures. That means for different zones we can have different values, or for different individuals we can also have got different values. So primarily accessibility is for a zone. We talk about attractiveness of that particular zone in terms of opportunities that are available, in terms of impedances, but also it depends on what time of the day, what activity, what are the other spatial characteristics are there in that particular area, and so on. So broadly, there are different parts in this. So we have already discussed the land use component is there, and within land use component we talk about the amount, quality, and spatial distribution of opportunities supplied at each destination. That means we not only talk about the total number of jobs, but we may talk about the quality of jobs, or maybe quality of something else, like quality of recreational facilities or quality of health facilities. So quality could be also brought in into this particular construct or this particular measure. And we can also talk about the spatial distribution of opportunities. That means how they are spread out in that particular area. So this is the land use component. It can include jobs, shops, health, social and recreational facilities, and so on. The demand for these opportunities at the origin location, that is also important. That means it's not about how many things are there in the surrounding area, but also what kind of demand do we have that for in the origin area. That means if I have got less demand, it will have less, that means it is not that demanded, so accessibility is be low. If the demand is also high, then accessibility would be higher in that way. Then there is also accessibility competition. That means if there is demand from different areas for those things which are in the surrounding area for this particular zone, then automatically the accessibility reduces. That means I am demanding something, but similarly others are demanding the same thing. Maybe others from other zones are also demanding the same thing. So definitely my chance of getting access to those particular opportunities will reduce. So this is called accessibility competition. So this is where confrontation between supply and demand for opportunities takes place, and this may result in competition for activities with restricted capacity such as jobs, school vacancies and hospital beds. That means there are some schools in surrounding area, but there is also very good schools maybe, so my accessibility is high, but at the same time the demand for these schools is also high. So my accessibility gets down because of competition from other zones. So that is also a part that needs to be considered. So in addition to land use part, we also have the transportation component, where we measure the disutility for an individual to travel using a particular mode between an origin and destination. That means here we are talking about the negative utility, because it's an impedance. That means it's a problem to travel. It's always a negative value which is assigned with a travel. That means it's an inconvenience for a person. So that's why we call it a disutility. It's a disutility for an individual to travel using a particular mode. So that means depending on the mode, the disutility value or the utility value will change. So certain modes are better, certain modes are not, and that also has to be estimated between the origin zone and the destination zone. That means from my zone to the activity, to the zone where the activity is there or the opportunity is there. So that is what origin and destination is in this particular case, and this includes amount of time, which is both the travel time, the waiting time, the parking time. All these things are part of time. It could include cost, it could be fixed cost, it could be variable cost, and it could be the effort. That means there could be reliability, level of comfort, accident risk along this journey. All these things could be part of that transportation component. And then again, in transportation, we can also have a measure for the infrastructure. That is, what kind of maximum travel speed is allowed in that corridor, that may play a role. So sort of level of service variables, the number of lanes in this particular area, in particular corridor, public transport timetables, how often bus headways and so on, we can consider those things, and then also travel cost. So these are the different transportation components that play a role. Then there is the temporal component. Temporal constants such as opportunities for activities vary at different times of the day. Similarly, individuals have fixed or flexible times to participate in activities like walk, recreation. So what it means is, for work activity, people have to go at work at a particular time. So it is a fixed activity. It has got a fixed time. Whereas for recreation, people may plan to vary that time period. That means he may decide to go at a little bit different time based on the kind of opportunity that he has got in terms of travel modes and so on. So temporal component do play a role in when we decide on accessibility, what time of the day, and also based on how flexible that particular activity is, the measures could be different. And finally, we have got individual component, which is like individual needs vary, individual abilities vary, and individual opportunities vary. So needs vary means age, income, education level, household situation, different things may play a role in the accessibility. For example, if I am studying in college, then I will be only looking at accessibility to colleges. If I am studying in school, I will be only looking at accessibility to school. So if I am working in IT, so I will be only looking at IT jobs, opportunities for that. So that means for each individual, the requirement that we are evaluating accessibility for also varies. The abilities, that means people's physical condition, ability of travel modes, all these things also play a role. For example, I don't have transit from my area, so I have to use my car or two-wheeler or even my bicycle. So that means the accessibility will be definitely impacted by that, or it may depend on people's physical condition. If I am an old person, then I have got only I can walk a certain distance, I cannot walk a longer distance. So that means automatically I am restricted to certain activities. So that may also play a role in my accessibility. And then opportunities like people's income, travel budget, education level, all these things also play a role. That means if I don't have the money, I cannot travel to a certain area, or because that area may not have a transit, I don't have money to afford for a car, so I will probably avoid going to that particular area. So all these things also play a role. And occupational matching for job accessibility gives a more realistic picture of job accessibility. That is true. That means if I am working in the service industry, if there are no hotels, in that area, there is that means my job accessibility is pretty low. But if there are other jobs, that actually is not having a role in my accessibility. So occupational matching is very, very important. That has to be considered when we talk about this kind of accessibility measures. So when we talk about accessibility, there are few basic axioms proposed by Weibull, and we can so some are primary axioms and some are derivations from that. Like for example, order of opportunities do not change accessibility value. That means the order is not important. Which comes first or second, that is not important. The total amount, quality and the distances, those are important. Accessibility do not increase with increasing distance or cost. That means distance is always bad. The more the distance, less is accessibility. And do not decrease with increasing attraction. So if attraction increases, that means opportunities increases, then automatically accessibility will increase. And opportunities with zero values has no effect on the accessibility values. So that means even if I have got many zones, but they have certain, they don't have jobs, that means that will not affect my accessibility. So in addition to that, there could be some other rules, like increase in demand for opportunities with capacity restrictions like hospital beds reduces its accessibility. That means when demand increases for this kind of fixed capacity fixed capacity opportunities, then automatically the accessibility value decreases. And then increase in number of opportunities do not alter the accessibility for an individual not able to participate in that activity. So these are things we have discussed, but these are the set of rules that we need to follow. And in addition, there are some other criteria such as accessibility should include behavioral basis and should be technically feasible and easily interpretable. That means we can create a very complicated measure for accessibility, but it would be both difficult to measure or it may not be that much easy to understand what it is. And then addition of a mode should increase accessibility. That means it should be such that when I add another mode, it should give me, it should reduce my travel impedance or rather increase my utility of travel. So that has to be there in my accessibility measure. Otherwise, it will not have any impact on the transportation policies that we may undertake, right? And then perceived or objective accessibility, sometimes people perceive the actual values and perception values are different. So that may also be considered while considering accessibility. So there are different ways we can measure accessibility. Accessibility influences both trip generation and distribution and land use choice models. So we have to understand that the different measures that we create for accessibility has to be, or rather the different formula that probably we will use for accessibility has to be in such a way so that it has got an influence on the different stages of trip travel demand modeling. For example, accessibility may change trip generation. It will definitely change trip distribution. That means people travel to areas which are the total trip distribution between an area depends on accessibility, of course, and it will have an impact on the land use choice models. For example, people will choose areas with with higher accessibility to choose to buy a house and so on. So land use choice models also depends on accessibility. So this is so accessibility measures could be classified in different ways. The first way to measure it is infrastructure based measures. For example, these are primarily used in transportation planning and service level of transport infrastructure such as level of congestion, average travel speed on a road network. These are the things that usually are measured or actually is used to determine what sort of transport accessibility that particular area has got. And then there are location based measures. Then these are of different kinds. The first thing is distance measure. That means we also call them connectivity measures. What it means is we just measure the straight line distance between 2 points, or that means with the existing point and the point of opportunity where it is where we are supposed to go, or which actually gives us the accessibility for which we are measuring the accessibility. Or it could be the average travel time speed between two locations. So either it could be distance or the average travel time between those two locations. It could be a contour based measure, for example, the number of opportunities within a given travel time or a distance or a cost. That means number of jobs available within 30 minutes of travel time. So that actually gives us a understanding about how accessible jobs are from my particular location, or how good the accessibility of my area considering jobs that are available. So in that way we can also create contour based measures. And then potential accessibility measures. These are gravity based measures where both the opportunity as well as the transportation component are considered. This estimates the accessibility of opportunities in zone I to all other zones, and smaller or distance opportunities result in lower accessibility. That means first of all we measure the accessibility of a particular zone and we measure it based on all the other zones that are present in that particular area. So it is opportunities in zone I to all other zones, right? So this is the first criteria. Second is smaller opportunities result in lower accessibility. That means more is the opportunities, more is the accessibility, and distance is the opportunity, lower is the accessibility. So again, with travel time reduction, accessibility increases. So this includes the combined effect of land use and transport both, and individuals' perception of transport is also incorporated sometimes using a distance decay function. That means is it a linear function? That means more the distance, more is the impedance, or is it a sort of where the distance is very high, the effect is very high, or compared to when the distance, it's not linear, it may follow an exponential form or a power form, something else. So that means this kind of form, how an individual perceives the distance, that means 10 kilometers and 12 kilometers, a person may perceive them to be same. It shouldn't be a difference, but a person may make a difference between 1 kilometer and 2 kilometer when they are talking about going for local shops and all. So this may have a larger influence, or it could be vice versa as well. So that means this individual's perception is also being incorporated. And then capacity restrictions of opportunities are also considered to include competition effect. That means we can also say that it's not only the number of opportunities that are there, but what others are, there is a demand for others, or there is a capacity restriction, that also has to be considered. So these are all part of the potential accessibility measures. Then there could be person based measures which are typically used in activity based modeling. We have discussed activity based modeling, where individuals decide on the activities for an entire day and so on, and activities in which an individual can participate considering spatial and temporal constraints actually gives him is a measure for his accessibility. So this is another kind of measure. And then finally we have got utility based measures, which are typically used in economic studies and is measured from the economic benefit that individuals derive from access to activities. That means the more access to activities, the more utilities, the more higher is the accessibility. So these are different ways these are being measured. In the next lecture we will probably look into different formulas, how to measure them, to give you an actual idea about how to form those utility of how to form these accessibility measures. So that is more, these are the different ways or the different types of accessibility measures that we usually consider. So this is one way of categorizing. Similarly, Professor Bhatt of University of Texas, he has categorized accessibility. This is a very popular paper, and he has used accessibility, categorized it in a different way. He has used the term spatial separation, cumulative opportunity, gravity based measure, log sum or utility measure, and time space models. So these are the different 5 ways he has divided accessibility. We will look into that in the next lecture. And we can just say that in the spatial separation measure, this is more or less similar to the distance based measure that we have just discussed. Cumulative opportunity measure is similar to the contour based measure. Gravity measure is as it is, as we have discussed. Log sum utility is the economic measure, and time space model is similar to the person based measures. So these are the different ways we can compare these two. We can go with both of these classification systems. More or less these are similar but different ways of categorizing. So there is another way some researchers have looked into accessibility. One is local and regional accessibility. Handy has discussed both local and regional accessibility by saying that while the accessibility may be same for a particular zone, considering both local and regional accessibility, but it has got different impacts that is created on the land use transportation system. For example, a particular zone could be very far from large activity centers. So that means impedance is high, but the attraction or the opportunities are high. So both are high. So like for example, there is a shopping mall, or it could be close. A zone could be close to many small activity centers. That means we have got small shops, the number of opportunities are less, but it is very near. So both of them may result in the same accessibility for a particular zone. But actually these have got two different dimensions altogether. For example, one is we are talking about neighborhood shops, and the other we are talking about shopping mall. But the accessibility score mathematically will result same. But at the same time, what we can say is this will lead to, because even though accessibility is same, this will lead to different travel patterns and characters of zones and regions. So this will, so this has got different kinds of accessibility. So that's why Handy has talked about regional accessibility and local accessibility. So activities contribute to local and regional accessibility based on the distance threshold. And this depends on willingness of a person to travel for these two types of activities and the amount of activity at the destination. So that means that the results, the activities that contribute to local and regional accessibility, that means there we can put a distance threshold, and this distance threshold could, the way we perceive these two kinds of distances, that means one on this side of the threshold and another on this side of the threshold, could be different. That means the local area could be, when we talk about distance, the impedance function would be different, whereas when we are talking about going to a shopping mall, when we evaluate between different shopping malls, we will use a different impedance function. So that means we will perceive local accessibility in a different way and regional accessibility in a different way. So if I use the same measure, then automatically this will result. That means we may have same accessibility, but it will have different travel. We may end up with different travel patterns, different land use patterns based on those accessibilities. So to detail this out, we can say this in the local accessibility, where we are same measures given by Handy. When we are talking about convenience establishments like supermarkets, drugstores, dry cleaners, which are present in any neighborhood and all. So there, these are small shops organized in small groups. These are standalone stores, and the trips are relatively short and also frequent. These are local trips, and choice of destination depends primarily on distance. That means I will choose the store which is near to my house. So both are, suppose we have got convenience stores in my neighborhood, I will choose the one which is near to my house in most cases, because they offer the similar kind of opportunities or similar attractive, both are of similar types of stores. So here you see in this local accessibility for I, the zone I, is based on retail, service and other employment. So jobs is the criteria that has been used to understand the quantum of this particular features, or rather quantum of this particular opportunities. And below we have the impedance function, which is time e to the power time ij between zone I and this particular opportunities in j, and here a factor is used which is 0.1813. So this is one function, this is a factor to this particular time, which is different from the factor which are used over when we are talking about regional accessibility. In regional accessibility, we are talking about regional retail, shopping malls and so on, and where customers are attracted from very, very far away. Here the distances are long, the trips are less frequent, so people are willing to travel more. So that's why here the factor is lesser compared to this particular factor. So that means the effect of distance is lower. So sometimes in many in future models that we will demonstrate in when we talk about trip distribution, or when we talk about location choices, you will see that sometimes people have introduced for larger values, people have introduced some distance of 10 kilometers, it is fine, but as soon as the distance become around 100 kilometers, probably people have divided it using a factor to lessen that impact, right? So what it means is when I'm going to a shopping mall, I'm ready to travel more because I travel once in a week or once in a month. So I'm ready to travel more. So the impedance, so I will not feel that bad to travel so long. So that's why the factor is less. The impact of this impedance or this function has got lower impact compared to this one. So what was the findings of this particular paper was higher local accessibility and regional accessibility, both of them are high. This leads to lower shopping distances but are not related to differences in shopping frequency. So this is the first finding. The second finding is high location accessibility along with low regional accessibility, high local accessibility along with low regional accessibility leads to lower travel and vice versa. That means, see, in an urban area we have to determine policies on should I focus on developing mixed land uses in my local neighborhood so that people will travel, will take care of all the different needs for shopping within the neighborhood itself, and very less, only a couple of times they will go to a regional shopping center. So if I want to make the total travel distance or the travel less for people, which is the target of most urban planning, like we try to reduce the total vehicle kilometers traveled, so I will probably give not only higher number of shops in my neighborhood but also lower the number of shopping malls. If both are high, that means the total retail for this particular city is met in both by shopping malls as well as local stores. If I increase the commercial activities both, then automatically it may not give us good results. But if I have high local accessibility and low regional accessibility, this leads to lower amount of travel and vice versa. But because accessibility is more or less same, it will not have too much effect on the buying habits or the opportunities that we give people to shop. So policies to improve both may have a countering effect. So that was the finding for this particular paper. So in addition to this concept of local and regional accessibility, sometimes, and then there was concept of mobility. So similarly, there is another concept which is called centrality, which is also very closely linked with accessibility. So it is not directly connected with accessibility, but it is to link to some extent that some of the measures of accessibility, when it talks just about mobility, is more or less related with centrality measures, and it is primarily used in social and geographic studies and in network analysis, this particular measure. And like for example, in social network centrality, and a person is considered to be central if he is close to all in the network. That means if he is connected to more other persons in his particular social network, then he is more central, or he is more accessible, we can say. So more informed, because it will the more connected he is, he will have more information, he will have more prestige and influence on others. So that's the reason. So if that person stands between others and facilitates communications through them, then that is also good. That means he is more compared to others, he can facilitate, inhibit or influence more. That means that's why in social network work we talk about influencers and so on. So you can see the person, if he is in between other persons, the more he is in between other persons, he can facilitate, he can inhibit, he can prevent, as well as he can influence. So these are the concepts of centrality. So centrality has been also identified in a way complex systems evolved. It may influence locational choices of activities and different centrality values corresponding to different functions. That means in some areas having more centrality, certain functions appear, whereas certain activities are taken place in certain areas which are more central. And centrality analysis has some similarities with transport network analysis and accessibility to some extent. So there are different measures of centrality. So the most basic measure is called degree centrality, where we measure the total number of links converging to a particular zone, or rather node, because we are talking about networks. So if you see in this particular example of a network, and here we have got these nodes 1, 2, 4, 3, 5, 6 and so on, and these are the links in between. So node 1 is connected with one link, node 2 is connected with 3 links, node 4 is connected again with 3 links, and node 10 is connected with 2 links. So accordingly, I have written down over in this particular table. So node 1 has got 1 link, node 2 has got 3 link, node 3 has got 2 links. So we find that the highest number of links a node has got is 3. So we give it a rank of 1. So there are 1, 2, 3, 4 nodes which are having a rank of 1, and then 9, 10, 5 and 3 has got a rank of 5 because first 4 places are taken up, and so on. So this is how a degree centrality measure is being evaluated. Then comes the closeness centrality measure, where closeness for a node is measured if it is less distance from the other nodes of the same network. That means how close I am to all other nodes in the network. So this is measured by taking a reciprocal value of the summation of the distance of nodes x to all other nodes. That means if I am node x, distance to all other nodes is being measured, and inverse to that is the closeness centrality. That means the more number of nodes that are connected, and also the distance to those particular nodes, the lesser is this value is better, because that means I am more closer to everybody. So that's why we take an inverse of that. So we can see that in this particular formula, where x is, we are calculating the closeness centrality of x, and we see that dg is from x to I. So this is distance from x to I, all other nodes, and we have taken inverse of that, 1 by summation I equal to 1 to n dg of xi. So this is the measure that gives us closeness centrality. Taking this in this particular graph, we say that for each node, like from 1, so some node is 2 is at a distance of 1, 4 is at a distance of 2, so is 3. That means one node is at a distance of 1, so 1 into 1, plus 2 nodes are at a distance of 2, 2 into 1, then one node is at a distance of 3, and so on. So in this way we will measure the centrality, the score for 1, and we take an inverse of that, which results in 1 by 34. And similarly we measure this closeness centrality for all other zones or these particular nodes, and these are the measures, and we see that these are the two values, like node 5 and node 6 are the closest to all other nodes. That is true because they are most centrally located compared to the other nodes. So these are more closer to all other nodes. So this has got a rank of 1, and then comes node 4, this one, and then comes node 7 as well, this one as well, because there is one link down. So this is how we measure closeness centrality. Betweenness centrality is another measure, where this is the measure of influence which could be defined by the ability of a node to bridge other nodes. That means a node is in between two other nodes, and usually it is measured by the number of shortest path between node pairs in which this node is located. That means every node to every node, from 1 to 2 there is a shortest path, from 1 to 3 there is a shortest path. The shortest path is definitely from 1 to 2 to 3. So this is the shortest path. So 2 has got one shortest path going through that. If I am taking 4, probably the shortest path between 1 to 5, 1 to 6, 1 to 10, all of them go through 4. So, but 1 to 3, this shortest path doesn't go through 4. So in this way we can measure how many of the shortest path goes through 4, and the more number of shortest path between any two pairs goes through a particular node, that node is of higher importance, because it is able to track the total number of connections between different zones, or it may be able to influence those connections or inhibit those connections. So that's why this is betweenness centrality. So this is given by this particular formula, where Gij is the total number of shortest path from node I to node j, and Gij(x) for this particular node x is the number of this above shortest path which pass through node x, and this is this is for both the zones 1 to of course the I, it doesn't includes x, and j is equal to 1, and for the other one j is lesser than 1. So in this way we can estimate for each node pair that we can estimate this particular value, and this gives us betweenness centrality. And then we have got efficiency centrality. This is actually a measure where efficiency of a node is determined by removing it from the network and then measuring the network efficiency. So we first have to determine on our efficiency criteria, and then we remove each node and see how the criteria varies. The one where it is mostly changes, that we call efficiency, that is of the highest accessibility or highest centrality. Then comes straightness centrality. This is connection is more efficient when path is straight. So if this is one way to measure centrality. Then there is eigenvector centrality, where centrality increases with connections to more interconnected nodes than to a less interconnected node. So that means the more one node is connected to other, not only other nodes, other interconnected nodes, that is better. So that means it is not only measuring how many nodes it is connected to, it is also measuring how many nodes those nodes are connected to. So this is similar to Google's PageRank algorithm, almost similar. It's not exactly similar. It is, the basic concept is more or less same. So these are some of the references. So to conclude the first part of this accessibility chapter, accessibility is an important dimension in urban planning, and it influences various aspects of the urban land use and transportation planning process. We will see that in most of the models or most of the travel demand estimates that we do, accessibility comes into play. Accessibility could be used both as a direct and indirect measure. That means accessibility could be used by other models to predict other things, or accessibility itself can predict certain things. Accessibility could be measured in different ways. The form of the measure should be as per the context, data availability and study objectives. In the next lecture, we will actually look into different ways to measure accessibility, the different formulas that are used by different researchers or in different studies. And then accessibility could be also measured in different scales, such as local and regional accessibility. And centrality could be defined as one way to measure accessibility. However, it provides a partial picture for accessibility. Thank you.